Central and inscribed angles of a circle. Here's some basic vocabulary. Radius. Segment from the center of a circle to a point on the circle. If you look below, there's an illustration of a radius. You can see that it's a segment that goes from the blue dot, which is the center of the circle, to anywhere on the circle. Chord. Segment connecting any 2 points on a circle. If you look at the second picture, you could see point A and point B. Those are 2 points on the circle, and the green straight segment connecting them is a chord. Diameter. Longest chord of any circle passing through the center of the circle. You could see in the first picture, there is a diameter. It starts and ends on the circle and goes through the center, thereby dividing the circle into 2 equal parts called semicircles. The little equation there is something that's always true. The diameter will always be equal to 2 radii. Arc. Rounded part of the circle connecting any 2 points on the circle. If you go back and look at points A and B on the second circle, there's a straight line connecting them, which is a chord. But if you walk around the circle on the rounded part of the circle, that would be called arc AB. And if you ever were referring to the two, we would say chord AB, we would say A, B with a line on top. And if we were referring to the arc AB, we would put AB where it begins and ends with an arc on top. Intercepted arc. Arc connecting 2 points on a circle within a formed angle. You could see in red on the second 2 pictures that the arcs that are within those 2 angles are called or referred to as the intercepted arcs. And then finally, the main idea of this lesson are central angles and inscribed angles. A central angle is an angle within a circle with the center as its vertex. It's always formed by 2 radii. As you can see in the third picture, that's a central angle. The vertex is the center and formed by 2 radii. And finally, inscribed angles. Angle within a circle with a point on the circle as its vertex. And it's formed by 2 chords. As you could see in that last picture, the vertex of that angle is also on the circle. So those are the basic vocabulary words of this lesson. Let's begin with central angles. Central angles are probably the easiest of all the circle theorems we're going to learn. A central angle is an angle formed by 2 radii with the vertex at the center of the circle. And quite simply, a central angle will always be exactly equal to its intercepted arc, both being 2 different things that can be described in degrees. So here, if you look at the picture to the right, you could see that there's an angle. The angle would be called AOB, O being the center of the circle, and A and B being 2 points on the circle. And the intercepted arc of that angle would be arc AB. And as you can see quite simply, as written below, that the measure of angle AOB would also be 82 degrees if the intercepted arc is 82 degrees. Let's do a few quick examples. See if you could pause the video for a minute and answer the 4 quick questions that are on this page. Okay, in this problem, they give us circle O. Whenever they name a circle, the point that is its name will be the center of the circle. They tell us that AB is a diameter, which means it goes through the circle. It's a chord that goes through the circle. And then they give us the angle AOC as being 60 degrees. Okay, well, before we even start this problem, we could come over here and say, well, angle AOC has O as its vertex, making it a central angle. So if the angle is 60 degrees, the intercepted arc will also be 60 degrees. Now, if we go back to the middle of this circle, we could see that we have a straight line, which is the diameter, and we have a radius OC. Well, we know that this angle and this angle are both central angles, but they're also linear pairs, meaning they're supplementary. So I could just say by 180 minus 60 that this is going to be 120 degrees. And if this is a central angle, its intercepted arc will be exactly the same as 120 degrees. Now, AOB, they also declared as a diameter, which means, technically speaking, we have a straight angle underneath here, making this 180 degree central angle, which means that the intercepted arc ADB, will also be 180 degrees. And of course, if we added up the whole entire circle or all the angles around a point, they're both going to add up to 360 degrees. So now it makes it quite simple to come down to our problems. Find the measure of arc AC. Well, we already did that. That's going to be equal to 60 degrees. And find the measure of arc CV. We already did that one, which will be equal to 120 degrees. And find the measure of arc ACV. Well, ACV is going to start right here. There's A. It's going to go through C all the way to B. Well, we can see, well, that's really just a semicircle. Well, or we can just add up 120 plus 60. That's going to give us 180 degrees. And find the measure of arc A, go towards D, and end at B. And that'll also give us 180 degrees. Pretty simple. Let's move forward. There are a couple theorems that we'll pick up along the way that we are going to use later in proofs. So just to run through these kind of quickly with you. Theorem 1 is stating that in a circle or congruent circles, congruent central angles will always have congruent arcs, right? It's kind of obvious, right? If those two angles are congruent, then of course their intercepted arcs will also be congruent. You could use that in a proof. And when it says the converse is also true, you can also do that backwards. If you know that arc AB is congruent to arc CD, and they both meet to make central angles, then those angles also must be congruent. Theorem 2, in a circle or congruent circles, congruent central angles will have congruent chords. So if you take those 2 points, A and B, and you connect them and create a chord, and you see chord AB and chord DC, that those will also be congruent. Okay, inscribed angles. An inscribed angle is an angle with its vertex on the circle, formed by 2 intersecting chords. Now here it's a little bit different, but not that difficult. An inscribed angle will always be equal to exactly 1/2 of its intercepted arc. So here, if you look at the picture, you could see that there's an inscribed angle, angle ABC. B is the vertex, and point B is on the circle, making that an inscribed angle. The angle hits the circle at points A and C, creating arc AC. And they're giving us the arc in this particular diagram as being 82 degrees. Well, since angle ABC is an inscribed angle, that angle will be exactly 1/2 of the intercepted arc, 1/2 of 82, which you could see written on the bottom. The measure of angle ABC is equal to 41 degrees. All right, let's take a look at some of these problems. Okay, number 13. Number 13, we could see that this point that forms the angle that they're asking us to find is on the circle created by two chords. They've given us an intercepted arc of 80 degrees, which would mean that x is equal to exactly 1/2 of 80, which means x would be equal to 40 degrees. It's that simple. If we looked at the one down here, it's almost exactly the same. We have an inscribed angle because the vertex is on the circle formed by two chords. That means that x would be equal to exactly 1/2 of 220, which means x would be equal to 110 degrees. Now here, these are combined problems here, right? So this problem, I could see that this point, well, I looked, if I don't have the given covered up, but that's the center, making that 80-degree angle a central angle. Well, central angles are exactly equal to the intercepted arc, which would make this also 80 degrees. And now I can look at this inscribed angle and say that x is equal to exactly 1/2 of 80 degrees. My x would be equal to 40 degrees. I call these Star Trek questions. And here we have another central angle of 60 degrees. That means the intercepted arc is also 60. The inscribed angle will be exactly 1/2 of 60, which would be equal to 30 degrees. Finally, two more. Here is just more elaborate but similar type questions. So in the accompanying diagram of circle O, the measure of arc AS is 64 degrees. It's not written in, so I'm going to go to my picture. I'm going to write in 64 degrees. What is the measure of angle RTS? I can see that point T is on the circle, making this right here an inscribed angle. And I know that inscribed angles are equal to exactly 1/2 of their intercepted arc, which means that should be equal to 32 degrees. Finally here, a slightly different variation. A new corporate logo created by the design engineers at Magic Motors is shown in the accompanying diagram. If chords BA and BC are congruent, okay, so I'm going to BA and BC are congruent, and arc BC is 140 degrees, what is the angle of measure B? Okay, so right here. Well, they're asking for the measure of angle B. Well, I know B is an inscribed angle. I don't have the intercepted arc. However, they did tell me that these two chords are congruent. Well, congruent chords intercept congruent arcs. So it should be kind of obvious to your eye that if this is 140 and these two arcs are the same, that this arc over here will also be 140 degrees. Well, if this arc here is 140 and this is 140, and we know that an entire circle adds up to 360, I could say, well, 360 degrees minus 140 minus 140, right? It's basically 360 minus 280, which will be equal to 80 degrees, meaning that this arc right here would have to be 80, because 140 plus 140 is 280, plus 80 is 360. Well, now I could say, well, that's an inscribed angle, so x will be equal to 1/2 of 80, which would be equal to 40. Not so difficult. A couple theorems, however, which are going to be used a little bit later. I would say the two on the left are probably more important for you to take a look at right here. So I just want to run through these. The first one comes up a lot on Regents exams. Theorem. An angle inscribed in a semicircle will always be a right angle, and therefore that triangle that could be created will always be a right triangle. The reason is that if you have an inscribed angle, angle C, to a semicircle, that would mean that this arc right here is going to be 180 degrees. Well, 1/2 of 180 will be 90. So no matter where you drag this point, if it's inscribed in a semicircle, that'll always be a right angle, and that'll always be a right triangle. So that one comes up a lot. It's an interesting one. And the other one down here all comes up a lot in similar triangle proofs. Here you could see that we have all those triangles inscribed inside a circle. Well, if you look at angle C, how they labeled it, and angle D, you could see point C and point D are both on the circle, making those inscribed angles. But if you look, they both are sharing the same intercepted arc AB. Well, if angle C is half of AB and angle D is half of AB and AB is the same for both of them, that would conclude that angle C must be congruent to angle D, right? Two inscribed angles to the same arc must be congruent. And this one over here on the right side, don't worry about that one for now. And there you have it. Let's leave it there. Those are the first two theorems. And when we feel comfortable with those, we're going to move on to the third, fourth, and fifth ones. So there you have it. If you have any questions, please post them on Google Classroom. And I'll see you at our next meet.